turn your textbooks, if you would, to page 125. Page 125. We're going to take a look at a word problem as we get started today. Work problem number 83 on page 125. And Brecken, you're there, so Brecken, if you'll go ahead and read problem 83 for us.
Gwen Chester has $41.70 in her piggy bank. She has one more than 3 times as many dimes as she has nickels, and she has 5 times as many quarters as nickels. How many of each coin does she have?
And now we know why there's a coin shortage in this country. All right, it's Gwen Chester's fault. All right, how many unknowns do we have here, Brecken?
3.
And they are?
Nickels, dimes, and quarters.
Nickels, dime, no pennies, huh? Maybe she's one of the, any of you like that? You're like, when you get change back, you're like, I don't want to keep any of the change but the quarters. I was weird like that. I know you're wasting money, but I'm like, quarters are big enough, they're not going to get, those other little coins, forget them. But maybe Gwen's like, I don't want pennies. Anyway, which of the unknowns gets to be X here, Brecken? Nickels, because everything comes back to nickels. What's the comparison between dimes and nickels?
3x.
Okay, because it says in the problem there that she has
3 times as many dimes as nickels.
Good, so we'll represent 3x. What's the comparison of quarters to nickels?
5 times as many quarters, 5x.
Good, 5 times as many quarters as nickels, so 5x. Now this does not refer to how much money she has, class. Listen to that again. This does not refer to how much money she has. This refers to how many coins she has. And if you're not careful, you think they're the same thing, but they're certainly not. This refers to the number of coins, but a number of coins doesn't necessarily indicate amount of money, correct? We not only need to account for the number of each class, but as you'll recall from last semester, we also need to account for the value of each. And of course, the value of a nickel, class, 5 cents. Now, if we've got it in terms of dollars, we'd have to do 0.05. But if you refer to it in terms of cents, you can just write 5. Does that make sense? Sense anyway. All right, the value of a dime, class, 10 cents, and the value of a quarter, 25 cents. So then once we know the number of each and the value or the cents of each class, we can then represent the total value, or in this case, the total cents of each. How do we get total cents, Maddie? We multiply these two columns together. So how many cents does she have just in nickels, Maddie? How many cents does she have just in dimes, Noah?
38.
And how many cents does she have just in quarters, Gavin?
125x.
Well, not 125x, just 125x. Yeah, and there we go. And this is how many cents she has from each type of coin. Now listen carefully to the question. How much cents does she have in all? Noah? According to the problem, looking at problem 83 there in your book, it says she has how much cents? Or how many cents? I'm not sure which is grammatically proper. In the very first line. Okay, you just gave me dollars and cents. I just want cents. So I'm asking you to translate. $41.70 is how many cents? Good. Do we see that? 4,170 cents. When you're taking cents, you just take the decimal out. So if this is how much cents she has from each of these, if you were to add all the cents together, it would equal 4,170. Now, watch. If I'd done dollars instead, 0.05, 0.10, 0.25, 0.05, 0.30, 1.25, 41.70, but in my equation, you know what I'm going to do with the decimal anyway? Move it 2 places. So why not start with it already moved? Does that make sense? Because mathematicians are lazy. So in a dollars and cents problem, if you'll start by translating everything into cents, it'll make your life a little bit easier. What should my equation be now, Maddie? And I'm not going to let you off the hook. And when we add all those x's together, what do we get? Let's do this, Maddie. What's 5 plus 120? There we go. 160x is what we get when we add it all together. All equal to 4,170. By the way, there is something we could do here to make our life a little bit easier. Yeah, let's cancel the zeros off. Something looks very wrong all of a sudden.
I think you forgot to add the 1.
She has what?
Yeah. One more than 3 times.
Oh, Brecken. I was just taking his word for it and nobody said anything. All right. I'm like, you cannot divide an odd number by an even number. It does not work. By the way, this is where math smarts saved us a ton of time. Knowing that odd doesn't divide by even, I'm like, something's wrong. Because think about it. Can you get a decimal here? No, because what is x? It's the number of nickels. Can you have a decimal number of nickels? So again, I know it has to be an integer answer, and I ain't gonna get no integer answer here. All right, so back to Brecken. When it says she has 1 more than 3 times as many times as she has nickels, I should have represented dimes how? 3x plus 1, which means when I multiply the 3x plus 1 by 10, I'm not going to get just 30x, I'm going to get 30x plus 10. So I end up with 160x plus 10 equals 4,170. Let's backtrack a little bit here. That's okay, we didn't have to completely redo the problem. 160x plus 10 equals 4,170. What would I need to do now? Let's go back to Maddie. Right. And that'll give me 160x is equal to 4,160. And of course, now I can go ahead and knock the zeros off. Now we've got even divided by even. Yes, and it'll work out now. And so now we can divide both sides by the 16. Class, help me here. 16 goes into 41. How many times?
2.
Only 2. Because 16 times 2 is 32, which means how many left?
96.
Good, 9 left over. So now 16 goes into 96.
8. 6.
Okay, 6 times. All right. Hey, at least he was answering. Y'all can't laugh. All right, x equals 26. So that gives me his number of nickels. To find the number of dimes, well, 3 times but 1 more than, like the book problem says, 1 more than 3 times as many would give me how many dimes?
49.
Oh, 79. And 5 times as many quarters gives me how many quarters? 130 quarters. And for sake of time, we won't check it. It does check out. But normally we'd say, okay, multiply this by 5 cents, this by 10 cents, this by 25 cents. See if it actually adds up to $41.70. We'll just say we're good to go. Did it say how many of each coin? Yes. And there are our answers, 26, 79, 130. Questions on this word problem? Note to self, double check students' answers before I just trust Brecken. I mean, he's a smart kid. He wouldn't lie to me, I thought. Now we know he's a liar. It's a shame. All right. Picking on Brecken now. All right, let's get back to fractions. We seem to do better with those. Fractions for the last couple of days. Talked about signs in fractions. Said there are 3 signs that I care about. Noah, what are the 3 signs in a fraction that I actually care about? The sign of the entire numerator, the sign of the whole fraction, and the sign of the whole denominator. So there might be a positive or a negative or something within a denominator. I don't care about that. If it's not the sign of the whole numerator, whole denominator, or whole fraction, I just don't care. But if one of those is negative, what's the rule, class? Move it out front so it becomes the sign of the whole fraction. If there are 2 negatives in there, cancel them. If there are 3 negatives, if all 3, are negative, Cancel the negatives in the numerator denominator, leave the one out front, so that whenever you write a fraction as part of an answer, the numerator and denominator are always positive. If there is a negative, it would be out front. And then we talked about reducing fractions. And we said you can only cancel... In reducing, you cancel stuff, right? But you only ever cancel... Oh,
No.
factors. You
Not
never
terms.
cancel terms.
No.
Hey, at least he answered. The rest of y'all being quiet back there. All right, so when you're reducing fractions class, you only ever cancel factors. You would never, ever, ever, Noah, cancel terms. Terms, no, only factors. So therefore, if you were to have polynomials, meaning greater than a monomial, you couldn't cancel anything because there's terms. What would have to happen first? Class? Factor, right? You can only cancel factors. What should I do? Factor, okay? Factor, and then of course cancel. However, if you cancel something out of the denominator, but it's not completely gone, there's still something left of it in the numerator, you have to make sure that you set that canceled factor unequal to 0. Let's practice with some of these at your seats. You can close your books for just a moment. I want you to reduce these fractions. Let's go ahead and take a look at this together. On the first problem here, Gavin, what do I do with the sign? Move it out front. Does anything cancel? Good. The M in the top with one of the M's in the bottom, so I still have one in the bottom. So my answer is? Did anything vanish from the denominator? No. We did cancel an M away, but there's still an M there. So here it looked like M couldn't equal 0, M still can equal 0. We don't need to include any excluded values. Now if you happen to write M cannot equal 0, that's not wrong. It's just more work. So if you're like, what do? When do I use excluded values, when don't I? If you just want to always state them, that's up to you. I'm lazy, I'd rather not if I don't need to. There's our answer on this first one. On the next one, Noah, what do I do with the signs?
You cancel.
All right, what else cancels?
The 3 and the 6.
To give me,
2 and 5.
all right, what else?
The X is canceled.
Okay, this X cancels with one of these to give me,
X is 4.
all right, what else? Okay, so the y's cancel as well. All right, so we can cancel this y with one of these to leave us with a.
1.
So what's our answer?
Y over 2x so 4.
All right, did anything vanish from the denominator?
The y.
The y disappeared, and it's still here. It didn't go away completely. It's still here. So I do need to specify that y does not equal 0. All right, how many had this answer for the second one? On the next one, signs. What do I do here, Brecken?
Cancel out the numerator and denominators negative.
All right, so I'm going to leave the 1 in front so that my answer is still going to have this negative. What cancels?
15, 25, 35.
There we go, pull a 5 or knock a 5 out of both of those. All right.
Take the A's and leave 1 A on top.
Good.
The B to the third on the bottom.
All right, B's cancel, leaving me with just 3 of them in the bottom.
And the C's cancel out.
C's cancel cleanly. My answer then would be negative.
Negative 3 A over 5 B cubed.
All right. What canceled out of the bottom?
A
And,
C.
but there aren't any C's left, are there? So we do need to specify, Brecken, that,
A equals 0.
but some people, some mathematicians would argue, we also need to state the C doesn't equal 0. What C? I'm not concerned about somebody making C equal to 0 when there isn't one left. So I would contend we don't need that, and there is our answer. How many had all 3 of these correct? All right, good with the monomials. Excellent. Let's take a look at polynomials now. Remember, where there are polynomials, you have to factor because we only cancel factors. We never cancel terms. All right. Check your answer to the first one. How many did you go on the first one? Good. Good. Question? Okay, you forgot to factor the top. You don't forget about common factor. I can move on to the next one. if you said on the second one, x can't be negative 2, you'd be right. What x? So you don't have to say x can't be negative 2. How many have 3/5 for the second one? Questions on the second one? Working on the last one then, if you're not finished. And checking your answer on the last one. Questions on